Good evening and welcome to the Royal Astronomical Society. Today is our March RAS public talk with Professor Kevin Walsh, who is the Astronomer-in-Residence at Westminster School, UK, and Professor of Physics Education at Shaanxi Normal University in Xi'An, PRC. He is a fellow of the RAS and the Institute of Physics, and the editor of the Bulletin of the Society for the History of Astronomy. He is also a co-teacher here for the RAS, where we teach GCSE Astronomy, a free 2-year course to, well, locals around in London. But over COVID, we opened it up nationally across the UK and had quite a few students. He did that with us, collaborating with my colleague, Dr. Sheila Kanani, and myself, and we collectively taught our 2-year course online during that time. And he's been very generous with us, supportive, and an inspiration to me and the many to look up, to study astronomy, and to teach the oldest science. Please welcome Professor Walsh.
Thanks, Lucinda, for that very generous introduction. And thanks, everybody, personal thank you to all of you for coming, and to you online. Sorry if I don't look at the camera when I should be. I'm not forgetting about you, I'm just forgetful. So my hope is that everything that we talk about this evening, no, it's not, it's gone dead again, you see, it's gone dead again, which is probably just me. I'm trying to, no, there you are, I did it. I've got the knack. My hope is that this is actually relevant to everybody, even if you're not a teacher of astronomy at any level. My hope is that because you've taken an interest in astronomy, however much, however little, because you may have experienced some teaching of astronomy, if you haven't done any teaching of astronomy, then it's going to be relevant to you. Okay? We're talking all levels, all backgrounds, all disciplines, and so on. So although the topic is going to be largely about astronomy education, I will mention some astronomy, but I hope that nevertheless the relevance is there for all of us. There's going to be two sort of broad parts to what I'm going to talk about, and being typical of me, I suppose, it's not sort of, first part, obviously the first part, second part, obviously the second part. It's going to be jumping between the two and melding and all the rest of it in a slightly haphazard way, but you'll get the idea, hopefully, as we go through it. But I'm going to begin by looking at the sort of the formal aspect, and the fact is, this is some of you will recognize this as the timetable, the exam timetable from a well-known school in London, snapshot. And look, there it is. This is this year. There's a paper on astronomy, and people are often very surprised. And we're obviously talking about the UK here and the UK examination system. People are often surprised when you tell them there is a GCSE in astronomy. They'd be less surprised if you said there was a GCSE in astrology. But when you say astronomy, they are surprised. And there it is. And there's two papers, and that one there is the second paper, as you can see. But it does seem rather odd sometimes that the subject of astronomy is there amongst all these other sort of traditional subjects. And if you ask people, not just young people, but people of all ages and all backgrounds about astronomy. So I often go into primary schools and give talks. And I will say, okay, we're going to talk about astronomy today. So what does astronomy mean to you? And they come up with all sorts of words, things like space travel, space science, space exploration, planets, stars, etc. All these sorts of things that are on there. So not many surprises, really. Oh, thanks, Lucinda. Let me see that a bit better now. But when I looked at this in a little bit of detail, there you are. Look, I've circled one word there. That's the word physics. Disappointingly small, really. And then you've got another one. Oh, there it is. There, that one just appeared. Did you see it? Research. Oh, dear me. Isn't it sad that there's such a small linkage in people's minds between astronomy and space science and research? But interestingly, there you are. Look at that one. Creation. Now, here we have something which might find a more comfortable place, shall we say, in a theological environment, creation, not just the physical aspect of creation, but any meanings behind creation. So it's already beginning to sort of tantalizingly suggest that this is a subject which has a very wide reach, and I'm certainly going to concentrate on that at some point in the next 40 minutes or so. I think in the advertisement for this evening, it mentioned the oldest science. And astronomy is often called the oldest science. I've called it the earliest science here. It might seem slightly odd because the word science didn't really come into being. It wasn't really properly coined in the way we know it today, and so about 200 years ago, something like that. So to talk about it, when human beings were emerging from caves is perhaps slightly odd. But you get the idea that this is something which captivated human beings naturally. Okay, we couldn't help it. We have this kind of pre-programmed yearning to explore, to observe, investigate the natural world around us, and the stars in particular, the heavens, have been particularly engaging. So no surprises that from the very first time we were able to sort of cogitate, we're able to try and think about astronomy as a science and treat it as a science. And we still have that today. However, humans have changed over the generations, over the millennia. We still possess this very natural, this very deep-seated yearning to find out about our universe. It's there. So it's something which I think we as as educators should be exploiting and making the most of. Exploiting is perhaps too strong a word, but we should certainly be making the most of it. We can't help thinking about the Earth, our Earth. We can't help but think about the place of the Earth in the heavens, in the universe, from as early as we can say we're thinking, really. But the question is, and the question I want to properly address tonight really, is what about learning about it? When do we start learning about it? When do we start sort of formalizing this thought and being a bit more, dare I say, scientific about it? There are lots of things which are natural hooks for this. Some of these things are so commonplace that we tend to overlook them, sadly. It's still amazing to see the sunset, I think, and the sunrise. It's an amazing sight. We shouldn't take it for granted. I do get slightly annoyed, wrongly perhaps, but I can't help it, when if I'm walking down the street and I see the moon, nice beautiful sort of half moon or something, I say, look, just stop for a second. Look, there's the moon. And somebody will say, oh, it's just the moon. What are you all excited about? But it's great. The moon is great. And the fact that it changes shape from night to night, the fact that it can get eclipsed from time to time is extraordinary. And we shouldn't let ourselves get blasé about these incredible sights. Satellites, this is actually not a meteor. This is a satellite streak. And you have to now count, rightly or wrongly, but you have to count satellite motions as sort of celestial phenomena these days. But it doesn't matter. These are still things which captivate us and which take us along that journey, help us along that avenue of thought. One can't help mentioning some slightly more captivating phenomena than these very familiar things like the sunrise and the lunar phase and so on. So what's that? Anybody want to shout out if they can identify what that? The Severn Bore, well done. Given that I used to live in Worcester, which is on the River Severn, I was known as a Severn Bore at one stage. But this is this tidal phenomenon on the River Severn, amazing thing. And what's that? It is. This is an eclipse from somebody called Charles Ullathorne that some of you may know. He took this picture in the States last week with his iPhone. It's not the world's greatest eclipse photograph, but it doesn't matter. He saw it, and the eclipse was something which captivated people. And this was taken by a gentleman called Andrew Mulholland, that some of you may know, in Iceland. And again, is indeed the Northern Lights. So these are more rare occurrences, but goodness me, are they interesting? Are they fascinating? And you can't help but be drawn into them, and they get you very, very excited. I think so anyway. We of course owe a great deal of debt to those people whose lives are all about presenting and popularizing science, and in particular, in this case, of course, astronomy. And forgive me if your personal favorite astronomy presenter is not on that rogues gallery. There are lots I could have chosen from, but I reckon the chances are they are there actually. I was particularly influenced, of course, by him, Carl Sagan. Well, and him, to be honest. But Brian Cox and Maggie Adair-Pocock are doing wonderful things today. And we mustn't overlook the impact that non-factual presentations and non-factual programs, TV programs, films, box sets, stories and all the rest of it have on engaging us with the astronomical world. Yes, it's true that Harry Potter might not be about astronomy, but there is an astronomy tower in Hogwarts, isn't there? And it's surprising how many names of people are actually stars that J.K. Rowling pinched off the celestial maps, which is fine. But we all know about Mr. Spock coming from planet Vulcan. Therein lies another tale, of course. But these figures, these stories are very important, and they are part of our education in astronomy, as is the exploitation of astronomy when it comes to humor. I can't resist when I look at Private Eye every other week and newspapers, just looking at these things. Now, the thing about cartoons, the thing that makes cartoons so impressive and so funny, really, so meaningful, is the fact that that cartoonist clearly has got a pretty good idea about the subject material. Okay, and they're making it believable to some extent. So, here we are, the possibility of launching the JWST upside down. Yes, it's possible, isn't it? And, it's amusing to think that this might have happened. I mentioned sunrises and sunsets earlier on. Well, we can make a little quip about that. And of course, does everybody here want to be an astronaut one day? Yes, of course you do. Everybody does. And you can jump in the spin dryer, can't you, to get a good idea about what it's like to go up in a rocket, maybe. And surprisingly, in my extensive research on the subject, which I'm proud to say I engage in every other week, as I say, Stonehenge features enormously in the cartoonist's world. But you see, this sort of thing here, I mean, there was a time when that would have been a contentious cartoon, really, because people would have said, well, is that what happens at Stonehenge? Is Stonehenge an observatory? Well, the studies are still taking place, as they are with all sorts of structures, ancient structures, stone circles, temples, etc., etc. So, there is a little sort of joke there, but it's actually quite a meaningful thing that's being said here, isn't it? So I'll come back to those sorts of extracurricular things, if you like, if I can call them that. But I'm just going to come on now for a short while to talk about the more formal aspect of a child's education in astronomy. And I am looking at UK here. It's interesting that earlier on when I was speaking, there were people from far-flung places of the world who were listening to me talk about the UK education system. So I wondered whether it was relevant or not, but they were very polite and said that it was. But a lot of this stuff is generic anyway. But as we know, in the UK, the 4 devolved nations have their own way of doing things. Some people say that it's just a deliberately way of just making themselves look different. But let's start with Wales, shall we? Why not? And the curriculum for Wales, don't bother reading all of that. I just picked out that particular phrase, which I think does identify the intentions of the curriculum for Wales and what they feel astronomy means to young people. It's a rich source of engagement for learners. Absolutely right. It really is a rich source of engagement. It's something which happens naturally, and it's not just specific to a small handful of ideas. It's very, very broad, and it's a way of bringing in all sorts of other areas of thought, other subject disciplines. There you go. There's the other 3, Scotland, Northern Ireland, and England. And I picked out these phrases from them. In Scotland, that learners develop their understanding of the Earth's position within the universe while developing a sense of time and scale. So trying to enable children to, yes, learn about space, learn about the universe and everything, but to get a sense of time their own time on this planet, the time that this planet has existed, the time the solar system has existed, the time the galaxy, you know, our little tiny portion of time in the great ocean of time of the universe, and our position and our space within it, how big the universe is, how small we are, how significant are we in that sense. In Northern Ireland, they looked at something which really did quite interesting me, how to survive in space. And I thought, does this mean that they're really worried that this is something which we need to know about? Like first aid, compulsory first aid. Look, you better know this stuff, because you're going to have to learn to survive in space one day, which is quite frightening. I don't think they meant that. I think they meant, well, look, if we learn about what it means to survive in space, then we automatically need to learn about what space is like. We need to learn about what it means to be alive, what sort of things we need in order to survive, and what sort of conditions there are in space, not just floating around in space, but maybe on other planets. So that's quite a profound and really interesting way of approaching astronomy, isn't it? And then here in England, from the national curriculum, I love the fact that they're looking at the subject as being something which enables children to raise their own questions about the world around them. So whilst we can go on about being educators and giving people answers, knowledge mongers and all this sort of thing, actually, one of the most precious things we can do is to continue to encourage people to ask questions and be curious, to celebrate being curious, and not, never sort of quell it. Once that happens as an educator, once you stop people asking questions, you're finished really, because that's your job as an educator is over as far as I'm concerned. Let's move on. I'm going to return to the primary sector in a minute, but I just want to move on as we get older with the children here, to secondary education, broadly speaking, sort of 11 upwards in the UK. 6 exam boards. We've got 3 in England and 1 in the other 3. And I just did a very quick look at what each of those boards does in terms of the inclusion of astronomy. And I also looked at a recent exam for each of them, which is this column here. So don't worry about all the details, and it's quite a busy little slide list, but this column here basically shows that the sort of astronomy that's being addressed by each of the exam boards, these are physics specifications, okay? Physics specifications, physics courses, is the same. So solar system, stellar evolution, cosmology, those sorts of things, they're pretty common to all of them. There might be 1 or 2 slight differences, but basically it doesn't matter where you live in the UK, the national curriculum of where you are, the regional curriculum will demand that these are the sorts of things you should be learning about as part of your science education, compulsory science education, okay? There may be 1 or 2 little optional bits here and there, but basically that's it. And interestingly, when I looked at the percentages that these things represent, they're quite rough and ready, to be honest, but they're all around the sort of 10% mark, I suppose you could say. And that's not too different. I mean, there's some little, enhanced values here, 16%, 15% here. But again, they're all around the sort of 10% mark of inclusion in the exams themselves, the terminal exams. So that seems to be quite clear to me what the exam boards and what the national curriculum, what the governments have decided is the importance of astronomy and the significance of astronomy in the physics curriculum. And remember, the physics curriculum is basically just 1/3 of the science curriculum, okay? So, about 3%, if you like, of the whole science education that a child will receive. Not very much, in my view. There remains only 1 available key stage 4, that's sort of, aged 16, GCSE level qualification. And that is this one. That's the Edexcel Pearson. That's the old London board, exam board, which is a really good course. And Lucinda mentioned that, she and I and others have been teaching it here and elsewhere for quite a few years. And it's a fine course. I'll say something more about that in a second. But we are a bit fortunate that it exists at all, because this gentleman here, who needs no introduction at all, or I nearly said no explanation, that wouldn't be right, would it? No introduction, tried to lump it in, if I can put it that way, with other subjects that were called soft subjects. Now, I'm not judging whether media studies is a soft subject or not. I'm not going to say that. But what I'm going to say is astronomy certainly is not a soft subject. I mean, all this suggests to me quite clearly is that the people who made this suggestion had never read the specification. Because if they'd done so, they'd have seen that you need to know about logarithms, you need to know about inverse square laws, you need to know about cubic equations, you need to know all these actually quite hard things, mathematically speaking, in order to do GCSE astronomy. Now, there's no way you can call that an easy ride. So anyway, it survived. Because of what was being suggested, a review was needed. And as a result of the review, some things changed. Not much, actually. Not much changed, if I'm honest. Like all the GCSEs, there's no assessed coursework component. It's just a sort of endorsement. And there were one or two introductions to do with ancient astronomy, which I think is good, cultural stuff. And then, of course, there's an emphasis on the current issues like exoplanets and space probes and so on. But otherwise, it remained pretty well intact. So when I was thinking about where all this came from, I couldn't help but go back to the start, really. And this was a bit of a sort of trip down memory lane, because I did astronomy O-level. Can you believe it? I know, all those years ago. And this was the book I used. It was really quite frightening to see this book. I don't know what edition I used, actually. Revised edition. I can't remember which one I had. But I was interested in the blurb on the back. Astronomy is now an O-level subject in GCE, General Certificate of Education, and figures in other school examinations. But since it is not yet often taught in class, those taking the subject have to do a good deal of study on their own, for which they require more than in some other subjects, a reliable ab initio textbook. Well, this book apparently was written by Patrick Moore, of course, in 1971. So the fact that he's writing is now a GCE subject suggests that it became an O-level subject in the late 60s. And that certainly squares with what I remember people saying to me. I mean, I did it a lot later than that, but it was still an O-level when I did it. 1971, that book was written. He's written those words, and they are as applicable today as they were now over 50 years ago. Half a century is gone, and this has not got any better, which I think is terrible, actually. It's a travesty. The book itself has evolved, and one or two others have chipped in, as you can see. There aren't many, though. There aren't many astronomy textbooks at all. This is the sort of go-to one that we use. Nigel Marshall used to be chief examiner of astronomy with the London Board. And this is a very sort of pared down, minimalist sort of book. He won't mind me saying that at all, but it has to be, because as we've already read from the blurb on Patrick Moore's book, people are having to spend a lot of time on their own. They're teaching themselves this subject largely. It's not part of the mainstream curriculum. So people are having to spend a lot of their own time, their own free time, their own valuable, limited free time studying this subject. And I think that shouldn't be the case. Fortunately, there are lots and lots and lots of websites available online to help you. Some of these are well-known, huge organizations, famous organizations, Royal Observatory Greenwich, BBC, etc. Ourselves here at the RAS. And that says to me two things. First of all, thank goodness that all this stuff is available. But secondly, it says clearly there's a need for it. There wouldn't be all this stuff if there wasn't an obvious need for it, an obvious demand for it. And it's a shame that there is such a demand for it, because it means that the provision is not there, both within school timetables and the usual sort of support, resources, textbooks, teachers of the subject. Let's move onwards and upwards from GCSE to the next stage, if you like, sort of post-16. But I've lumped together a few things here, actually on the advice of somebody I spoke to earlier today, to be fair. And I've added one or two things here. But in recent years, the Astronomy and Astrophysics Olympiad has been introduced. It's quite new. The British Physics Olympiad has been around for a long time. The International Physics Olympiad has been around for a long time. But this is now a new move to introduce astronomy and astrophysics, which is great. It's not compulsory. It's a competition. It's for those that are keen and able, and it exists. And thank goodness for that. That's super. And there are lots of other things like competitions. And universities like UCL have the Orbits program, which introduces postgraduate students helping students, school students, looking at real research data, which is fantastic. And the use of robotic telescopes, the Fawkes telescope, the National Schools Observatory, others, NASA have such a thing as well. So, you know, children of all ages can engage with these things and use these things in their own sort of personal study of the subject. Of course, astronomy exists as a formal topic post-16, but not on its own, as part of A-levels. Sometimes optional modules in A-levels and baccalaureates, but never a huge amount. I have to say, and I'm sure she won't mind me saying this, but I was talking to somebody earlier today, so I gave this talk earlier today as well, who said that she started doing A-level physics because she wanted to do astronomy. And of course, the first thing she studied when she did A-level physics, which some of you will be familiar with this, was things like electricity and mechanics. And she thought, this is not astronomy, I want to do astronomy. And when she was told that astronomy would be studied, you know, a year and a half later, towards the end of the second year, and it'd be for sort of half a term, she said, well, I'm sorry, I'm not going to do physics A-level anymore. And that's terrible. It's really very sad that the provision was not there. Because of course, there's stuff to do beyond A-level as well, as we'll come on to. Now, I do need to mention something called EON, which was formed very recently, the Astronomy Educators and Outreach Network. Just last month, as you can see, we had a meeting. And I think it's fair to say that this kind of evolved out of, an almost desperate need in the astronomy educators community, for there is one, you know, small though it might be at the moment, when we were in the midst of the pandemic and we were having to come up with teacher-assessed grades and mock examinations and coursework and all these sorts of things. Now, teachers of astronomy across the country in schools are rarely astronomers, it's fair to say. When I was at school in Cardiff, in South Wales, all those years ago, one of my teachers was my maths teacher, who said, listen, I don't know any astronomy at all, but I can help you with the logarithms, I can help you with Kepler's laws, if that's any help, and it was. And things like, you know, coordinate systems, those sorts of things, the mathematical, geometrical side of things. But, you know, you're incredibly lucky these days if you're in a school that has a specialist physics teacher that can teach A-level. And you're even more lucky from the astronomical point of view if you've got a teacher who has an astronomy specialism, because otherwise those astronomical topics are kind of lost. And to think of the number of students who get to that sort of age and are either not being taught those subjects at all, or are being taught those, you know, with the greatest respect to those people who are doing the teaching, because it's amazing that this is being done at all. But people, you know, shouldn't be expected to do it. Just like biologists shouldn't be expected to teach physics, which is happening up and down the country. But so this sense of isolation that prevailed during the pandemic meant that it was inevitable, really, that we had to get together. And we did. And here we are a few years later where EON has emerged. We have to remember that almost all the students doing GCSE astronomy are doing it in their spare time. Okay, they're not doing it as part of the curriculum, they're doing it after school, an after-school club, a society. You know, they're coming here, for example, as we do on a Thursday. It's an extra thing in their lives. And again, if we're honest about it, the sort of people who do GCSE astronomy are the sort of people who are already very busy. They're just that sort of person. They like doing lots of things. So they're trying to squeeze something into these ultra-fine cracks in their lives, which is really hard. So it's a challenging subject, you know, conceptually, mathematically, and they have the extra challenges of how they go about it, how they're taught it, how they're learning about it. EON exists, as I say, as something which has emerged from the pandemic difficulties, but it is fair to say that because it is You know, if you look at the words here, Astronomy Educators and Outreach Network, it's saying nothing about ages. So we have actually got people in the group from primary schools and indeed from universities. So that's great. That's a really good development. And I'm urging people, including some of you here, to become part of that network. So one of the things which, as I mentioned at the very start, in my slightly haphazard way I'm trying to get across here, is how ubiquitous astronomy education is. Yes, it forms part of some very definitive formal curriculum work in schools, in specifications, but there's so much of it beyond that as well, which if we're trying to administer the education and trying to guide the education that people are receiving, then there does need to be some kind of holistic awareness and some kind of steering going on. Otherwise, the whole thing can lead to difficulties, which I'll come on to in a minute. But there are lots of other organizations, of course, which dabble in this and which help out in this. The guides and the scouts have activity badges. You know, they have activity badges for things like, you know, making knots, or, you know, identifying flags and these sorts of things. They also have one for astronomy, I'm pleased to say. And they do traditional things like, you know, tell the time using the sun and these sorts of things, which is fantastic. Identify the constellations, you know, find the North Star from the plough, these sorts of things, which is brilliant. But again, it's going to be helpful, isn't it, if that's something which is part of a sort of, you know, coordinated plan, if you like. Otherwise, the thing can get very, very messy. But the point is as well that this is something which clearly appeals, and we do need to be exploiting and making the most of that natural appeal. Yes, there are lots and lots of clubs and societies, local clubs, school clubs, but provincial clubs, you know, municipal clubs, as well as national organizations as well, including this great place. And I can't resist talking about the amazing work when the RAS celebrated its 200th birthday 3 years ago. It offered grants to people who came up with ideas that would take astronomy to, you know, to boldly go where no man had gone before, sort of thing, if I can quote Star Trek. And you did have these amazing projects up and down the country, in other parts of the world as well, I think, where astronomy was being used and in a way that it hadn't been used before, and people were able to access in a way they hadn't before. And it's tremendous, actually, all the work that was done. But we are always, whichever of these things we're talking about, whether we're talking about formal education, whether we're talking about, you know, a curriculum setting, or in, you know, in less formal environments, we are always risking as educators, if there is the need for a formal study, and we know that people are naturally interested in it, then we have to be mindful of the fact that it's very easy for what is a hobby and an interest and a passion to actually lose that appeal when it becomes formalized. You know, I mean, the dreaded exam is enough to put anybody off. Okay. You know, of course, examination systems are important. Of course they are. But we all know that, you know, if we're sometimes we can do something for the love of it, and other times if being forced to do something because there's an exam at the end of it, that can have a detrimental effect. In some subjects more than others, I acknowledge, but certainly, you know, I've found over the years that I might have a really, really keen student, like that one I mentioned earlier on today, who disclosed that she gave up A-level physics because there wasn't enough astronomy in there, and it's just not what they thought it was going to be. And as soon as you start throwing, you know, celestial coordinates and Newton's law of gravitation at students who just want to learn about stars, planets, and black holes, you run into trouble. Beyond school leaving age, beyond A-levels, you have, of course, university education and higher education. And I totted up that there are 47 UK institutions offering 238 degree courses, or degrees, I should say, or courses, which include astronomy. Some of them might be largely astronomy, many will be you know, physics with astronomy or that sort of thing. I have included, by the way, I just totted them all up, so that includes postgraduate degrees as well. A huge amount of astrophysics. I suppose it's obvious that a lot of astronomy departments are part of, mathematics departments, but more usually physics departments. I did come across two particular courses, by the way, which interested me. Science and Space, and that was actually part of a geography. That was run by a geography department at a university. I think it was Bristol, actually. And how about this one then? Cultural Astronomy and Astrology. There you are. Get the astrology word out there. Why not? Come on, don't shy away from it. It exists. And whatever your personal beliefs of the whole thing, we cannot deny that culturally, astrology just is perhaps worth studying, and there are links with astronomy. Historically, of course, some of the great astronomers that we know about, Johann Kepler, for instance, Tycho Brahe, these people were employed as astrologers because astrology was important. Dr. John Dee, Elizabeth I's, guru, he was an astrologer, and a lot of what he said, based on astrological observations, determined, which dress she wore, whatever day, these sorts of things. But anyway, it's quite interesting, isn't it? Again, from the past, once you'd done your astronomy degree or you were heading in that direction, people said, you've got to think about, the rest of your life, and, people were being encouraged to join the Navy to see the world, but of course you could become an astronomer and see the universe, which is a much more appealing thing, isn't it? Although these days, again, sorry to keep going about my childhood, which is obviously a very happy childhood, I'm pleased to say. People said, well, look, if you become an astronomer, you can go to Chile, you can go to Hawaii, Siding Springs in Australia, you can go to all these places, won't you be lucky? And sadly, these days, that's not really the case, because you can sit in your office, in Imperial College, and you can be using a telescope on the other side of the world, without ever leaving your desk. So perhaps the travel is not so widespread as it used to be. But anyway, mustn't let that put people off. Let me come on to something I alluded to earlier on, after a quick time check. Yep, we're okay. And that is misconceptions. I was delighted when earlier today, when I gave this talk, this guy, Neil Cohens, here he is, was there. He was online from the US. And in fact, he wrote to me afterwards, which was very nice, and thanked me for mentioning his book, because this book's had a big effect on me, actually. It's great. So he lectures at a university in Maine, I think it is, and he's an astronomer, and he was keen to find out what sort of misconceptions first-year undergraduate students of his had in astronomy. And he was blown away at how distorted, shall we say, some of the understandings were and some of the beliefs were. Now, these are people who, they were scientists, these young people. They'd had good educations, in the US, not that backward in terms of its education system, and yet, and the sort of things he was looking at, what causes the seasons? How does the moon change shape and size as you look at it? Does it? And if so, how does it? Where is the moon in relation to the Earth? Where are the planets in relation to the Earth? How big is the solar system? Have we got any idea? If I jumped in a car and I could drive to the moons in a straight line, I know you can't, but I mean, if I could, how long would it take me? A day, a week, a month, a year? Have we got any idea about these sorts of things? What causes the tides? Well, no, not only what causes the tides. How many tides are there a month? How many tides are there? How often are the tides? And even here in London, with one of the world's great rivers, children do not know how many tides there are a day. I'm not going to embarrass people by asking them here. You look at the stars from night to night, if you can see the stars. If you go out the following night or the night after that, are they the same stars at the same time? Are they in the same position? If not, why not? How do they change? Why do they change? These are such fundamental things, and they're just passing people by, or even worse, people are getting the wrong idea about them. And it's distorting their view of their home planet and of the universe they're in. And that's quite worrying. And my concern is that these are things which persist. So Neil wrote this book a while back, but I've been mindful of these misconceptions for a long time. They're not getting any better. They're not getting any, there are no improvements. The misconceptions are persisting in spite of technology. One might even argue because of technology. But we'll come on to that a bit later on, perhaps. Last year, when I was on a sabbatical, I did this little sort of tour of the UK. There you are. These are, they're not all the schools, but they're pretty well all the schools I visited. And I put them, as you can tell, not in a random order, but that looks like the UK, doesn't it? That's the outline of the UK. Have you got it? Isn't that good? But don't worry. I mean, you know, Silverstream is in Northern Ireland, which is meant to be up here. For example, you know, Gravel Hill is actually near me in Bexley Heath down here somewhere. Oh, St. Peter's is in London, I suppose. But anyway, that's not the point. The point is, it was a sort of UK-wide survey, if you like. And I'm still, whenever I encounter primary school children, you know, and give them a survey on this, you know, I try and sweeten it with a planetarium show or something like that. But actually, I'm just interested in getting the handle on their misconceptions. I want them to provide data for my survey, and they are mostly 10-year-olds in primary schools and all sorts of schools, I'm delighted to say. And there's no doubt about it that when I went around all these schools and continue to go around all these schools, I'm nothing but impressed, absolutely impressed with the zeal that the children have for learning, the things they know, yes, it's disturbing the things that they either don't know or have got a, you know, a wrong handle on. But I mean, there are lots of other things which they do know, which I'm really impressed by. And the teaching which is taking place in these primary schools that I've been mentioning has been fantastic. Really, really amazing work. So you can't fault all that. But in spite of all this, there are still lots and lots of misconceptions. And I think there is this continuing need to address and develop and exploit this natural interest. But we do need better resources. We need a better assessment of the curriculum. We need to have a better designed curriculum, and we need to train people to do it, to deliver that curriculum without, you know, having a sort of hand-to-mouth existence and doing something, you know, on an ad hoc basis. Those misconceptions. Interestingly, this was just, when was this? This was February, does it say? February. Yeah, February the 6th, 2024, look. So very recent. This was in the Sky at Night magazine. Great. It's a great publication, Sky at Night magazine. But when I read this article, several things struck me. These are the so-called 8 astronomy myths that they mentioned. I'm not having a pop at the Sky at Night Astronomy magazine. It's brilliant, okay? But I think I wanted to use this article to make a point. These are the 8 myths, and these are the actual subheadings for each of those myths. The moon appears at night. Is that a myth? Well, no, the moon does appear at night. I think what they mean is, the myth is that the moon only appears at night. That's the myth. Some people think the moon only appears at night, and of course it doesn't. But we've got to be a little bit careful, haven't we, how we couch this. Stars twinkle. That's not a myth. They do twinkle. But do we mean the stars themselves, or is it the atmosphere doing something? Earth's distance from the sun causes seasons. Now, actually, okay, that's quite a famous one, that people think that, you know, in the summer, we're closer to the sun. By the way, well, I remember when I was once, this is when I was at a conference last year of postgraduate students, astronomy PhDs, okay? Astronomy PhDs. And we were talking about artificial intelligence, actually, as it turns out. But I couldn't resist giving them a little sort of survey of their own. And when I just mentioned, this was slightly cruel of me, but it worked. I talked about the elliptical nature of the Earth's orbit around the sun, and I kind of planted that. And then I asked the question, you know, a bit later on, oh, and you know, what causes the seasons? Now, of course, perhaps because people have been sensitized to this varying distance of the Earth from the sun, they immediately equated summer with being closer to the sun, as you would. Now, we all know, with our interest in astronomy, that it's to do with the tilt of the Earth. That's what causes the seasons. We're actually closer to the sun in January. January the 4th is when we're closest to the sun, when it's perishingly cold in England, okay? But that's when we're closest to the sun. Yes, but we're tilted away from the sun. It's not a distance thing, it's to do with the angle at which the sun is striking the atmosphere. Now, that's quite a well-known idea. But do you know what? In my survey, huge numbers of children knew that the Earth's distance is not the reason for the seasons. They knew about the tilt of the Earth. So in a funny sort of way, this idea that this is a myth is a myth. And we've got to be careful of that. We're perpetuating myths. We're saying, yes, well, people have never understood this. It's a myth. And, it's a sort of self-fulfilling prophecy, isn't it? We've got to be so careful about that sort of thing, really. There's a dark side of the moon. Well, notwithstanding the Pink Floyd album, of course, but there is a dark side of them. There's a dark side of the Earth. Every day, there's a dark side of the Earth. That's not what we mean, is it? That's not what they're trying to get at. We've got to be so careful. It's not the same side that's always dark, is what we're saying. Okay, so we need to be mindful of these misconceptions. Remember, we're talking about educating children here and educating people. It's not just the children, but everybody has these misconceptions. I'm just going to say something about astronomy now as an educational tool in this increasingly interdisciplinary, cross-disciplinary, multidisciplinary, as I've written here, world. Now, of course, a lot of astronomy is physics and maths. And if I'm honest, I do tend to rely on students knowing a lot about the astronomy from physics and having the mathematical capability, as I mentioned earlier on, in order to be able to do the subject. But there are all sorts of other things in astronomy, not just at GCSE, in astronomy in general. There are all sorts of subjects which all come together in this great, under this great umbrella of astronomy. It's to my mind, a paragon of multidisciplinary learning. And if we're growing up in a world where multidisciplinary learning and the need for cross-disciplinary skills is important, then what better way of nurturing that and developing that than focusing on a subject like astronomy, which is going to bring these things on and has the added advantage of being something that people are actually interested in, which they are. Everybody's interested in astronomy. Let me give you two examples which have appeared in the esteemed magazine A&G, RAS publication. Archaeoastronomy, written by the excellent, well, me, and Xi'An, who was a student at Westminster. She and I put together this little article, which is all about how you can examine the structure of, say, a stone circle in a way that relates it to celestial phenomena. So in other words, was the study of the heavens influential in the design and building of, say, a stone circle? How, like Stanton Drew in Somerset, which I visited and which actually I think I mentioned in this article actually. But and there are lots of temples, pyramids, all sorts of things, geographical features, lined up with stones. There's all sorts of disciplines in there: geography, history, anthropology, archaeology, you name it. And this thing called STEAM, which is really what I was getting at here, the power. I didn't think of this type of, the editor thought of this, which I thought was quite good, unleashing the power of STEAM. Science, technology, engineering, arts, mathematics. So it's all in there, okay? Archaeoastronomy has the lot, as they say. And then at a slightly higher level, postgraduate research level, you've got things like biosignature science. How do we know, in inverted commas, what the atmosphere of an exoplanet contains? And we're hearing all the time, aren't we, about, this planet, Kepler, such and such a thing, the name of this planet, it has an atmosphere that could sustain life. Now, immediately people think, well, isn't that amazing? And it is amazing. How do we know about it? Well, a team comprising, yes, astronomers, but engineers, computer scientists, biologists, chemists, mathematicians, all sorts of people come together and actually do things which lead to these conclusions. They contribute in ways that can lead to these conclusions. So this again was being mooted, look. Biosignature science come a long way in half a century, but its future depends on more interdisciplinary feedback and conceptual innovation, interdisciplinary work, bringing together these disciplines. I'm going to mention very quickly, has to be very quickly because I'm up against the wire again, aren't I? PQs, project qualifications, which have been around for a while, and I could say a lot about them, but I'm just going to mention two of them really. That's the HPQ, the higher project qualification, and the EPQ, the extended project qualification, because these are, I think, really good vehicles for astronomy qualifications. Now, what I'm trying to fish for here is a way in which you can balance, you can make that seesaw balance. You can continue to motivate children and develop their passion and retain their interest, whilst at the same time get some sort of formal qualification for it. And you don't want the passion for the subject to get in the way of the formal qualification, and you don't want the formal qualification to get in the way of the passion for the subject. You want to be able to do both. And I think project qualifications, which are coursework-based things, are a good way of doing it, should we say. Students have their own decisions to make. They decide on a question that they want to answer. They decide on the direction. Yes, we help them a little bit, but it's largely independent work, which is fantastic. And they retain that interest. They become little experts in their field, which I think is fantastic. So these are two which I'm going to mention that I've personally encountered. So a couple of years ago, I had an HPQ. We did an HPQ almost as an experiment, actually during COVID, has to be said. But one I had, this is one that they will do at age 16. So this is a sort of GCSE version. Should humans go to Mars? And it's quite good because it talked about the ethical side of it, as well as the, how would you do it anyway? And, the financial aspects. There were all sorts of things in there. Again, multidisciplinary. And then last year, we had a student who asked if Tycho Brahe, did he have a big effect on the Copernican revolution? It's accepted that he did, but what sort of effect did he have? This was really good. There's a lot of very good research in there. So I'm a big fan of it. We can't ignore the fact that a lot of teaching is being done virtually. So we were saying earlier that when I gave this talk earlier, we had people from all over the world tuning in, which was great. It was really great. It would have been nice if they could have come here and filled this room, but actually, what would you prefer? A full room and nobody outside the room knowing anything about it, or a sort of half full room and people all over the world? Well, it's interesting, isn't it? It certainly makes it more accessible. But this is something I got involved with last year and the year before, actually, which is to do with the use of dialogue in teaching. So in a real classroom, dialogic teaching is very important. When you enter into a dialogue with an individual or a group of people, how does that impact on the teaching and learning that takes place? How do you direct it? What sort of things are happening? And the interesting thing is, how does that vehicle, how does that aspect of teaching translate into the virtual world? There's something called the dialogic space in a real environment. So where in the virtual world is the dialogic space? It was very, very interesting. And I'd like to maybe get Donkin to come here and talk about it. But certainly when I was doing a lot of online teaching and continue to do so, I'm a big fan of simulations, in particular this one. Some of you will recognize it and know that I'm a big fan of it. It's not the only one, but I think it's particularly good. But it does enable students, anybody who's learning about astronomy, to learn not just about the nature of the night sky, where the stars are and how they move and so on, but about the mechanics of the universe and the scale of the universe. There's a huge amount of information available in this free program, this free online program. And it does enable people to experience astronomy. I think that's the crucial thing. Okay, and we could go on to talk about AI. I'm also a big fan of planetariums as an experience, or planetaria, if you're being pedantic about it. Planetariums. This one, of course, which one is this? It's the Baker Street Planetarium, but it doesn't exist anymore because Madame Tussauds took it over. So there are stars of a different nature in that building, if you see what I mean. But there are planetariums all over the country, which is great. And here's one. This is in Greenwich, of course, the Peter Harrison one. This is in Armagh, the observatory and planetarium in Armagh in Northern Ireland. This isn't the one I use, but it's one very much like the one I use. Mobile, in inverted commas. It's really heavy and it's very bulky. It's not very mobile at all, but nevertheless, there it is. And this one, which I encountered last year at a maintained school in Woking, Surrey. Yes, you heard it here. A maintained school in Woking, Surrey. It's a planetarium. It's a real planetarium. It's fantastic. It's really good. Everybody should go there. But not everybody can get to Woking or wants to go to Woking. but it's there, and it's a resource which, you know, should be being used and should be accessible to so many people. We should all be able to go to planetarium. And I think this might sound a bit cheesy and slightly romantic, but I do think that, you know, the beauty and wonder, I don't want to sound like Brian Cox, I'm not going to put on a Mancunian accent like Brian Cox, but, you know, the beauty and wonder of the night sky is something every human should experience, and the earlier the better, without a doubt. Because I do think, in all seriousness, I suppose, you know, the older I get, the more I believe this, that the more we're learning about Earth and its place in the universe, and the more we're learning about the universe, the more we will appreciate where we are now. So, you know, when we give this is a planetarium show that I give this some of my students, you know, we always finish up by saying, listen, we've talked about black holes, we've talked about supernovae, we've talked about galaxies, exoplanets, talked about all these things. But you know what? The most amazing thing of all of these things that we could mention is right here. Here it is, Earth. And by learning about the universe, by learning about all these other things, we are hopefully appreciating a lot more the precious nature and the extraordinary nature of where we are. So here we are. Here's a few things, just as a sort of wish list. Wouldn't it be great if it was a mainstream subject, a timetable subject that everybody had to study in depth up to GCSE? As you heard, I do have links in China, and I'm very interested in how the Chinese learn astronomy. I was chatting to somebody from an exam board in this country who told me that Mongolia, the Mongolian government, decided against adopting a UK GCSE in physics because there wasn't enough observational astronomy. There wasn't enough about identifying constellations. So they rejected it because this is what the people in Mongolia want to know about, because it's in their culture. And they need it, and they like it, and they want it. So there you are. What we used to call remote teaching has now become virtual teaching. So yes, somebody's remote if they're a long way away, but the virtual world has brought people together, hasn't it? And that's a wonderful thing, don't get me wrong. But I don't want to see the virtual classroom as a substitute for the real classroom. It'll never be a substitute for the real classroom. It became a substitute for the real classroom because it had to, because of the pandemic. But you would not, you know, you would not advocate that it is a substitute for the real classroom. It's different. We should just forget that the pandemic ever happened if we can, start from scratch and say, okay, this is a virtual classroom. How is this going to operate? And you'll find that there are different ways of doing things. There need to be different ways of doing things. You can't replicate, you shouldn't try and shoehorn real life classroom practice into the virtual world. It doesn't work, but we need to use it. Of course we need to use it. There needs to be more formal post-16 qualification. There should be an A-level in astronomy, quite bluntly. And there needs to be more planetariums. You can't have enough planetariums. I'm saying planetariums rather than planetaria because I think it's better. But everybody should experience the planetarium. And I mean that, you know, quite profoundly. The door is open, okay? We are pushing, as they say, against an open door. So let's keep pushing. And let's, you know, let's get these things done. I think it's people who are interested in astronomy, people who are interested in learning and teaching about astronomy. We need to make these feelings known, and we need to do something about how astronomy is being taught as a subject to people in a formal sense, in a more rigorous way. And we do want to make sure, of course, that we are educating people in a way that informs them, but also helps them to appreciate the world they live in, and to take care of it, and to respect it, and to realize how precious it is. Thanks ever so much for coming and listening. I'm happy to take any questions as long as they only last minus 30 seconds. Oh no, I forgot to get the microphone.
Getting it out now. But while we do that, I can ask one question that I saw on Zoom. I think Alex Gauss, is that a student from your school?
Alex Gauss? Is it G-A-U-S-S?
Yes.
Oh, no, he's probably some great mathematician, great grandson.
Well, they ask, for A-level subjects, what do you recommend if they have an interest in studying astronomy?
At university, maths, physics, And then one other, I would say something, I mean, the obvious one's chemistry. And I'm not just saying that because I've got a certain colleague here. But, you know, I would say something, you know, geography. Maths, physics, geography, that'd be great. That'd be a great thing to study, a great trio to study for university. You have to do maths and physics. But in a sense, you know, I think the multidisciplinary nature of astronomy is such that it doesn't really matter what the third subject is. History, do history. Maths, physics, history, brilliant. Classics, great. Art, super. Yeah. Try it, you know, whatever your interest is. And there'll be an outlet for it in astronomy, I promise you. Thank you, Alex, for your question. Thanks for it not being too...
Testing. Any other questions?
Don't be shy. Come on, I know you do. I can see it on your faces. Or is it just tedium? Go on. Oh, yes.
You had quite a worldly audience this afternoon. Today we have one question. From YouTube, Matthew Henson, who was actually here for your 1 o'clock, online as well for your 1 o'clock, asked which textbook, astronomy textbook, I'm assuming, is your favorite? You did show several.
Yes, I did. And those the textbooks I showed. Can I go back to them? The textbooks I showed, just while I'm thinking my answer, were ones that are the obvious ones to use these days. And in fact, I should say that they're ones which, you know, you don't really have much choice. Okay. And if you're going to go for something which is paring it right back and which is almost a revision guide, you have to have that because you're feeding it into the cracks in your life, as I say. So Nigel Marshall's book, I'm not being unkind to Nigel, but oops. Oh, perhaps I am being unkind to Nigel by switching him off like that. But anyway, oh, hang on. Yeah, there you are. This is a very thin book, okay, as we know, we use it. Deliberately so, because unlike other subjects, you can't spend ages, you know, looking at lots of photographs and reading about the stories of the lives of astronomers and all this sort of thing, which is really interesting. You just haven't got time. So I think if you're studying GCSE astronomy, yes, of course, I would advocate these books. I think my favorite, I mean, I'm not on commission or anything, but my favorite is the Phillips Dictionary of Astronomy, which I think is a great book. And I think is one which, you know, it's a good reference book. But if you're reading about astronomy and you're studying astronomy, it's good to have that there as something which you know, has all the answers to. So I'd go, yeah, I'd say that.
It gives you guys some time to think about what you're going to ask.
You're not going until you ask a question. Okay?
Yeah.
Knocking the doors.
Question on Zoom.
Yes.
Kind of in the same vein, but for teachers, do you have any recommendations of any books for non-specialist KS2 3 teachers? Not a textbook style, they say, but something, but a fun read for pure interest.
Yes, well, I'm going to be biased here, and I'm going to say the sort of upgraded version of Carl Sagan's book Cosmos. Some people might say, "Oh, that's a little bit dated." It's not, because it's you know, a lot of it is historical anyway, and it was updated. But the point of it was based on a sort of personal journey through astronomy. It's very readable. It's very accessible. It's very accurate. It's fascinating. It brings together lots of ideas. It brings together people. It brings together events, you know, national events, world events. It brings together circumstances as well as the science. And I think it just makes it just brings it alive, quite honestly, rather than just being a dry subject, you know, with just worked examples. It's all in there. I'd say it's a real page turner, even today. Carl Sagan. Ah, well done. Well done. You drew the short straw by the sound.
I just was going to ask, how do you sign up for the Astronomy Educators and Outreach Network?
Sorry, can you say that again? I didn't quite.
Sorry.
It's probably easy, but
Oh, hi. How do you sign up for the Astronomy Educators Outreach Network?
Thank you very much.
Because it sounds...
It's a very good question. Very easy one to answer.
Okay.
If you give me your email address, I'll pass it on to Jeremy Thomas. Jeremy Thomas, who's the coordinator. So we can do that. Yes. Do you mind me asking why you asked? You're perfect. Yes, definitely. Seriously, yeah. It's exactly the sort of thing you should be signing up to.
I just wanted to add that he is, I guess, the person in charge now of Pearson Astronomy. So that's why he set up that.
That's right. Yes, so he was to do with, I'm not sure if he's anymore, but he used to be part of his net, that's right. Oh, Ben.
No, Jeremy.
Oh, right. Is he? I didn't know that. I thought he was, but yeah. He's something with Portsmouth University as well. Yeah. But he's the man. And this is the organization. Definitely. Yes. I'm afraid we haven't got time for any more questions.
Thanks, Kevin. That was really, really interesting. It's clearly an interdisciplinary subject, but perhaps the closer cousins would be the other sciences, the physics, chemistry, and biology. There are only 6 exam boards, as you say. What, as a chemist, can I do to lobby for more astronomy elsewhere?
Yeah, well, thank you. That is a good question. And the problem is that this has to begin, like many of these things, it has to begin at government level. It has to begin with the sort of legal curricula, the stipulations on the part of the government as to what the national curriculum framework needs to be. They're called, aren't they, national frameworks, I think, in the Fordham. And so astronomy needs to get its own space and recognized part on that framework. And I mean, I was thinking about this earlier on. Something like meteorology, you might remember this actually. Meteorology years ago, how important is meteorology? I mean, how important is the weather in Britain? We're always talking about it. We're obsessed with weather. It's so important, not just out of interest, but it dictates our lives. We need to know about it. It's interesting. It's important. Do we learn about it at school? Well, you might learn a little bit about it in geography. Well, I can remember when I first started teaching, there was a debate as to whether it should be in physics or chemistry or geography or, a separate subject. Nobody really knew where to put it. And I think the same thing has happened with astronomy. Astronomy has found a nice little home in the physics curriculum at GCSE and, of course, at A-level. Now, there's a separate GCSE, which is unusual. There's no separate meteorology GCSE, but there is astronomy. But at A-level, it's never going to happen unless a lot of people say, well, look, I'm teaching something in my subject, chemistry, biology, whatever, which clearly has relevance in astronomy. So, why not have a separate subject? Why not create a separate subject and stipulate on the national curriculum that these things need to be taught? Once that's the case, exam boards will then say, okay, these things need to be taught. We will devise an exam which people can take and pay their fees for and all the rest of it, and then you can take your qualification, an accredited exam. But it'll need a lot of pressure on governments. And Paul, I was saying earlier that Paul Roach in Cardiff is actually part of the National Curriculum for Wales development team, and he's pushing hard to get more astronomy on the curriculum for Wales. And if it reaches a certain mass, then there will, they might well develop their own GCSE in astronomy in Wales, and maybe even an A-level. But it's getting it in at that government level. So my advice is, okay, this is the real answer to your question. In a general election year, write to your MP. Okay, yes, thank you.
I think it's for the people online.
It's for the people, yeah.
Sorry, I just wanted to ask, how do you actually kind of get into astronomy education? As like either formally or informally, like what are some like pathways that you could kind of take?
Right, okay, that's a good question. Well, I mean, if you're a science teacher, if you become a science teacher, then you can then take courses here, and the Royal Greenwich Observatory and UCL is the other place, wasn't it? UCL is a good place which does sort of postgraduate diploma courses in astronomy, which will enable you to then add the astronomy as a kind of body of science work into your teaching portfolio. And so as a science teacher, you can then teach astronomy. But it's not quite the same. Unfortunately, when you train to be a school teacher in this country, you might do a PGCE, a postgraduate certificate in education, in physics or in chemistry or in maths or something. You don't do it in astronomy. That's the problem. So the best thing you can do is to do it in, say, physics, and then study the astronomy, with the UCL or something like that, and just build up your own knowledge to the extent that you can then teach it at GCSE, or whatever level you choose to do it. So, you know, become a science teacher in the usual sort of way, and then take whatever courses you might need to take, you know, do the GCSE. We have had adults doing the GCSE, and then you can add that kind of ability and that awareness and knowledge and skill to your general science teaching. That would be my advice. I don't know if anybody else has any other advice they want to add on that, but that would be what I would say.
Wonderful. Thank you
We're
so
going to have
much,
to finish there, but thank you so much.
Professor Walsh, for being with us. That's okay. It is worth it. Thank you so much for being with us, and let's thank Professor Walsh again for his talk today. Thank you. Can we get the lights? Thank you.
Thank you all so much for coming. And I'm going to go to the tavern now.